So let's start with our lecture. Is whiteboard clear to you? Anyone?
Yes, sir.
So yesterday we solved one question in which we figured out the stresses due to the inclined loads which were acting on the cross section, or in other words, I can say we figured out the stresses for the case of unsymmetrical bending of for symmetric sections. Now we will continue with the same concept, and here I would like to discuss another idea. In the case of symmetrical loading, or when the loads are acting, for example, on principal axis, what happens is we have bending on the perpendicular axis or the other principal axis. Now, in this case, we know for sure that this there is an axis, which is this axis basically, on which the stresses are zero. That's why we call this axis as neutral axis. But when the loads are acting inclined to this one, inclined to the cross section or inclined to the principal axis. Now, in this case, we have to transform the a resultant movement. For example, if movement is something like this one, then we have to transfer this resultant movement in two direction or in two components along the principal axis. Now, in this case, the movement is acting on two axes, right? One is this x-axis, the other one is this y-axis. Now, in this case, there will also be an axis. So, what will be the neutral axis? Will
जी
it
सर।
be this one or this one? Yes.
सर वो 063 ने अभी मुझे कॉल की सर। वो कह रहा है कि उसका माइक नहीं है आज। वो पीसी से काम कर रहा है, लैपटॉप उसका खराब है, तो इस वजह से वो अपनी अटेंडेंस बोल ना सका।
Okay. So,
और सर मेरा भी लेखपाल है, मैं अभी ज्वाइन हूँ थोड़ी देर पहले।
okay. So, coming on to this one, there are the movement is acting on two axes. One is this x-axis and the other one is y-axis. So in this case, the movement was acting on one axis alone, and that axis was also on neutral axis, because the reason was that the stress on that particular axis is zero. And why stress is zero? Because in this equation, if we see on this axis or on this perpendicular axis, our y distance was equal to zero, and therefore there won't be any stresses in that axis. That this is our definition, that the axis on which the stresses are zero is our neutral axis. So can anyone give me idea where will be the neutral axis in this case when unsymmetrical bending is taking place?
सर किसी inclined पे
सर
होगी शायद।
इंक्लाइन ही होगा।
So there will be an inclined plane, right, on which the stresses will be zero. अब वो inclined plane हम find कैसे करेंगे, right? तो उसके लिए हमने एक we developed a simple derivation in which we will use the same concept, that on neutral axis we know that on neutral axis the stresses are zero. And if you remember, in the previous class we developed this particular equation for resultant stress, right? Now in this equation, if you look clearly, this is the equation for sigma z is equal to, and these are the two stresses or stresses due to two movements mz and my. Now look into this figure, this is x and this is y, and I have assumed that the neutral axis will have a clockwise angle with respect to horizontal axis. And let's suppose that the resultant movement or the initial movement that was acting on this cross section is acting in the clockwise direction from the horizontal axis, or from the original horizontal axis, you can call it like that. Or I can say that this beta, now these horizontal axes are also principal axis. So beta angle from principal axis to from horizontal principal axis to neutral axis, and theta is the angle from horizontal principal axis to moment axis. Now you should remember these two angles clearly, that from where is this angle, because these directions are fixed and any other direction, for example in the question, if I have given you this particular angle, for example this one, then you don't just substitute this angle into this equation. You have to find out this angle, which is the clockwise angle from the horizontal principal axis to the moment axis, because we have completed or we are going to do our derivation based on these angles. Okay, only then you will get the correct answer, otherwise there will be some deviation from the actual answer anyway. So whenever we are doing some derivation, the figures that we plot or sign conventions that we use are very important, and you have to use the same conventions in the equations that you derive. Now let's suppose these are the cases where there is a moment which is acting at an angle theta, and we have assumed that our neutral axis is at angle beta. Now if we can find out some equation for angle beta, then we can easily figure out for all cases that where is our neutral axis. Now for this particular scenario, we have this equation for resultant stress, and I know that on neutral axis the stress is equal to 0. So we will assume over here that our stress is equal to 0, and this is our myx, the same thing. If I simplify from this one, I will get this particular equation. I will take this myx or mxy on the other side, and then I will get this equation. Now in this equation, if I see clearly, if I resolve this moment or resultant moment into two components, one will be in this direction, and that is mx cos of theta, or m cos of theta, I can call it that, and the y component will be m sine of theta. Now these two components I have shown over here, that uh, if I further simplify this one, take my onto this side, I will get these two, this simplified equation. And when I substitute the values of these, I will just solve it briefly over here. Myx over iy is equal to mxy over ix. If I substitute the values of my and mx into this one, I will get my is m sine of theta into x, iy equals to m cos of theta into y over ix. This m will cancel out, and I will be left with y over x equals to sine theta over cos theta and ix over iy. Now if I further simplify this equation, I will get, now this is y over x over here. Can I say that this y over x, this is y, this is x? Can I say that this y over x is equal to tan beta, because that is also perpendicular over base? So y over x is tan beta, this sine theta over cos theta is tan theta, and then this ix over iy is again our moment of inertia. Now this is the equation which I have developed for inclination of neutral axis. So if you are given the moment of inertia of the principal axis and the angle theta, which you can figure out easily in your question for resultant movement, then you can find out the orientation of neutral axis. Now, if you get positive answer for from this equation, that will mean that this orientation is clockwise with respect to horizontal principal axis. Over here you can see that we assume the direction as clockwise from horizontal principal axis. So if it is positive, then the direction will be same. If you get the negative answer, the direction will be counterclockwise from the horizontal principal axis. So it depends on these conditions that what answer are you getting. So this is how you find out the inclination of neutral axis. So any confusion about this one? So this is it about most of the theoretical concepts related to unsymmetrical bending of symmetrical sections. Now let's move on to some example problems. I will just So this is the problem that we are going to solve first. In this one, we have been given a cantilever beam, which is shown over here, on which there are two loads that are acting 14 pound and 1000 pound. And also the cross section properties are given to us. Iy is 18.7 and Iz is 112.6. Now we know that for this particular beam, this Iy and Iz are also the principal axis, because Iy is the symmetrical axis and the axis at 90 degree with respect to that one is also our principal axis. So we have been provided with the moment of inertia of the principal axis, and it carries two concentrated loads. One is 1000 pound and another one is 14 pound. And we need to compute the angle between the neutral axis and the horizontal plane or the principal plane, or in other words I can say that we need to figure out the orientation of neutral axis. And the next thing that we need to do is to find out the maximum tensile and compressive stresses in this beam. So these are the two things that we need to find out. First, I am going to solve this problem 3 because it is a bit easy for you to pick up. Then we will move on to these. Both are same problem. The only difference is the type of beam that we are using. So in this one, again, we have been provided with a simply supported beam, and the distances are given, all the dimensions are given, and we need to find out the angle between neutral axis and horizontal. And it has mentioned to us that if the working bending stress is 12 ksi, we have to find the largest allowable value of the load P. Now in this case, we have to work in some different direction. For example, normally it asks us to find the stresses. Now in this question, it has given the question we have been provided with the stress itself, and we need to figure out the load. So what will we do? For example, if this is our equation, then in this equation we will substitute some correlation of movement. For example, let's say movement is P8, then we will simplify this equation and get the value of this load. So you can expect any type of question. In the previous problem that I have shown you, we were supposed to find out the stress. Now in this one, we are supposed to find out the load. So you can expect any question with respect to any variable. So let's start this question. So first thing is obviously that we need to figure out the angle between the horizontal and neutral axis. Okay, uh, I will just solve it over this cross section. So for that angle, our equation was tan beta equals to Iz Iy into tan of theta. So Iz, it has been given to us, that is 112.6, Iy is 18.6. So can anyone tell me what is this angle theta? What will be angle theta?
-60 होगी इसमें।
-60। अच्छा, ये एंगल था किसका, पहले तो ये बताएं।
Sir, horizontal to यहाँ पर लोड लग रहा है उसमें, मोमेंट मतलब मोमेंट वहाँ प्रोड्यूस हो।
मूवमेंट लग रहा हो, तो इस डायग्राम में मूवमेंट लग कहाँ रहा होगा?
सर पी की डायरेक्शन में लग रहा होगा।
पी की डायरेक्शन में या उसके 90 डिग्री पे कोई एक्सिस होगा? ऐसा नहीं होगा कि यहाँ पे कोई एक्सिस होगा जिसपे मूवमेंट लग रहा होगा,
यस सर ओके।
because there is, as we discussed this thing yesterday as well, that there will be an axis at 90 degree with respect to this load जहाँ पे movement लग रहा होगा. So I can show it as 90. So let's suppose the movement is something like on this axis and this is the direction. Okay, so this angle is 90. What will be this angle? This one.
सर 60 होगी सर, 90 माइनस 30।
60 कैसे?
30 होगा सर, 30।
ये एंगल कितना है? ये 60 होगा. Then this
यस सर,
angle will be 30 degree.
30 होगा,
And
30 होगा।
now if we look into this angle is clockwise with respect to horizontal principal axis. So that means we have to substitute the positive 30 degree. If let's suppose अगर ये just for the sake of example I am showing you कि अगर मेरा मूवमेंट एक्सिस इस तरह बन रहा होता है, ये ग्रीन वन, और ये एंगल 30 होता, उस केस में मुझे यहाँ पे वैल्यू -30 सब्स्टिट्यूट करनी पड़ती, क्योंकि विद रिस्पेक्ट टू हॉरिजॉन्टल प्रिंसिपल एक्सिस में देखूं तो ये काउंटर क्लॉकवाइज ओरिएंटेशन है, ठीक है. बट इन दिस केस इट इज क्लॉकवाइज विद रिस्पेक्ट टू द हॉरिजॉन्टल प्रिंसिपल एक्सिस, सो आई विल सब्स्टिट्यूट एंगल एज 30 डिग्रीज. So tan beta is equal to Iz is 112.6, Iy is 18.7, and tan of 30 degrees. So what is tan beta or beta angle? Quickly, can you give me the angle?
73, sir. 73.9.
So the angle is 73.95 degrees. So if I want to show this angle onto this beam or on this cross section, so if these are my principal axis and this is my moment axis. Okay. Let me use a different pointer. Now this red one is my movement axis, which I have shown over here, and this angle was 60 degree, which we calculated using our the same concept that the moment axis is at 90 degree with respect to the applied load. And then since I have got positive answer over here, so I have to move 73.95 degree in the clockwise direction, and the axis at that particular point is my neutral axis. Now in the case of symmetrical bending, when the loads are acting on principal axis, the moment axis and the neutral axis were same and they were coinciding. But in this case, you can see that since there are two resultant moments which are acting on both y and z axis, the position of neutral axis is slightly different from the original moment axis, because उसकी reason same है कि आपके पास दो axis पे load लग रहा है, जिनकी वजह से एक resultant axis sort of thing बनेगी जहाँ पे stresses zero होंगे, और and we use the same condition to figure out the angle for that particular axis. Okay, so this was the first step in which you were supposed to find out the orientation of neutral axis. Now the next thing is that it has given to us the working stresses. Usually the working stresses are the maximum bending stresses. So to find out maximum bending stresses, for example, this is the bending formula Now, if we are given the maximum stresses, we need to substitute maximum moment into that equation. So if I look into my beam, what will be the maximum moment in terms of P? Or what will be the value of this resultant moment? Since we have the load given in terms of P, so we can only find out the value in terms of P variable. So if I solve this,
P by 2 multiplied by 8.
yes, what will be this reaction?
P by 2, sir.
Since it is acting at the center, so the reaction will be P by 2. So either I can plot the bending moment diagram, or I know for sure from directly by looking at this figure that the maximum bending moment will be acting at the center, and its value will be m maximum P by 2 into 8. Over here, all units are given in inches, so I will convert this 8 feet into inches as well. So this will give me the value as 48 p kips inch. So this is the maximum movement. Now, what will be the direction of maximum movement with respect to this centroidal axis? We discussed yesterday how to figure out the directions. Can anyone? वन जीरो फोर क्या होगी डायरेक्शन मूवमेंट की? जीरो फोर फाइव 421.
जी
क्या होगी मूवमेंट की डायरेक्शन?
मूवमेंट की डायरेक्शन सर क्लॉकवाइज।
मुझे शो क्या करनी है विद रिस्पेक्ट टू सेंट्रॉइड? आउटवर्ड शो करनी है, इनवर्ड शो करनी है, ये कैसे करनी है?
सर इनवर्ड की तरफ शो कर, इनवर्ड।
क्यों?
सर मैंने कल वो वाला लेक्चर नहीं दिया, इसलिए मुझे कोई इतना आइडिया नहीं है इसका।
कब लेंगे कल वाला लेक्चर?
सर बस वो मिड की तैयारी में लगे हैं, इसलिए ये
You
वाला।
know, this is one of the most important topic of this course, and I
सर
don't see
फिर मैं
your whole class is not paying attention to any of this stuff. I'm seeing in last 3 or 4 lectures, so I don't mind it, but you will be in trouble later on. These are not simple things. Anyway, about the direction of movement, as we learned yesterday, that first we have to figure out that which load is producing the maximum bending moment in this beam. So we know that this P by 2 is producing the maximum moment at this point, and since it is producing the moment in clockwise direction, so the resistive bending moment will be in the opposite direction or counterclockwise direction. So if it is in counterclockwise direction, then I have to show my resultant movement outwards from the centroid or centroidal axis. So this is the P load, and over here I have already shown the direction of resultant movement outwards with respect to centroidal axis. So that will be 48p. Now I know that in the question I have been given the maximum bending stress, and considering that maximum bending stress, I have to find out the maximum loads or the value of P. So if I write the equation of bending stress for this equation, that will be again minus mz Iy over Iz. So Iy, sorry, that will be myz over Iy minus mz y over Iz. Now this is my equation for bending stress. In this equation, I need first two things. One is my, the other one will be mz. So anyone can tell me what will be my? कितना होगा my?
So m sin theta.
So that will be obviously m sine theta. And if I look into this figure, the m sine theta will be going upward in this direction, and the angle theta is given to us as 60 degree. So
सर ये एंगल तो 30 डिग्री नहीं है सर.
by the way, this angle was 30 degree for the moment. So the angle is given to us as 30 degree for the moment, and if I write the equation for my, that will be 48p sine of 30, and mz will be, again it is in the positive z direction, so that will be 48p cos of 30 degree. So what is the simplified forms in terms of p? कितना आएगा ये?
my is equal to 24p.
So my is equal to 24p and mz is equal to, I guess, 41.57p. Now I have two values of my and mz. I can substitute into my governing equation and I will get 24p into z divided by Iy was given to us as 18.7 and my is 24, sorry, mz is 41.57p divided by Iz was again given to us as 112.6, and this is it, and there is a term y over here. Now I need to find, and this bending stress was also given to us. What was the value of bending stress? I think it was 12 megapascal or 12 Gibsons. So now we have been given with this all these factors, and I need to find the maximum value of load P, because I have been given with a working stress, which is usually the maximum bending stress. Now to find the maximum value of P or maximum value of bending stress, when will this maximum value occur? When I substitute the parameters Z and Y in such a way that both these terms add up. So is there any way that I can remove this negative sign?
Minus
Anyone?
y particle relation.
So we can substitute the maximum value of y in terms of or maximum negative value of y. So maximum negative value of y कहाँ पे होगी? There will be some point at this location, right? जहाँ पे y की कोई value होगी, that will be the maximum value, right? And from the question, we know all the distances as well. Over here, if you see that I know all the distances, and if I can figure out the maximum value of y and substitute in this equation, so इसका मतलब क्या हुआ कि that there is a point B on this cross section जहाँ पे ये stress 12 KSI find की गई है because it has been a maximum stress. So let's substitute the values of z and y into this equation. So that will be 24p and z at this point B. What is the value of z? Over here, if you look into this one, we are provided with the thickness, and the value of z will obviously be half of this thickness. So that will be 0.5 divided by 18.7. And in the same way, now the y distance will be negative. So this negative will multiply with this one, and we will get this as positive. What will be y distance? Y कितना होगा?
ये 3.07 है.
इस B पॉइंट पे
5.93 sir.
5.93, because the total height is given to us as 9 inches and this height will be 9 minus 3. The total height is 9, so it will be 6 point something, right?
ये
Sir,
5.93.
0.07 minus करना.
5.9. Yeah, I don't have the answer, so I will just. So the y distance is 5.9 into 5.9 divided by 112.6. So now from this equation, if I get the value of P, what is my answer? Can anyone solve this quickly and give me the answer?
सर 4.25.
4.25. Can anyone else check this? I don't have the answer for this one, so
Yes sir,
I'll
4.25 sir.
so when you solve this one, you will see that you are getting the load as 4.25 kips. Just let me cross check.
एक्सक्यूज मी सर,
Yes.
सर ये बता दें कि आपने ये माइनस साइन क्यों खत्म किया?
मैं बताता हूँ. Okay, yes, the answer is 4 point something. So let's say 4.25. I have eliminated the negative sign because over here, if you look into this figure, I have taken this point B as my uh, point of consideration. I have considered this B point because the reason was कि मुझे maximum bending stress चाहिए थी या कोई ऐसा point चाहिए था जहाँ पे bending stresses maximum आती. ठीक है, अब उसके लिए मुझे क्या करना था कि मुझे इस इक्वेशन को मैक्सिमाइज करना था. सो आई हैव टू फाइंड अ पॉइंट कि जहाँ पे ये वाई डिस्टेंस नेगेटिव में हो. अब वाई डिस्टेंस नेगेटिव में कैसे होगा कि ये जो मेरा न्यूट्रल एक्सिस है या ये सेंट्रोइडल एक्सिस है, इससे y एक्सिस पॉजिटिव, अगर इससे डिस्टेंस अपवर्ड होगा y, then it will be positive. If the distance y is downward with respect to my centroidal axis, then y distance is negative. So यहाँ पे मैं ये कह सकता हूँ कि ये जो 5.9 था, that is negative 5.9. For example, I can write it here. for convenience that it is negative 5.9 because it is in the opposite direction with respect to the positive y-axis. That's why I have eliminated this one. By the way, there will be another point. For example, let's say I call this point as C. Okay, so इस C point पे कितना होगा y distance या x distance, z distance
3.07 होगा सर।
और
Y
z
distance।
कितना z
Three.
कितना होगा
3 होगा
तो
सर।
z
होगा
will be 3.
0.5।
Can I say that z is minus 3 because that is in the opposite direction, right?
Yes sir.
So z is minus 3 and y is minus 3.07, positive 3.07. So in this case as well, both these terms will add up to give you the stresses. But when you find the answer from this one, you will get the load as 2.41 kips. So obviously you have to report the maximum value of load. So you will consider this term. So in some of the cases, you might have to do 1 or 2 trials. So it won't be more than 2 trials. So in some of the cases, you might have to do this. So just be careful while you are assuming the points. So obviously in this one, we can get the clear idea that this distance 5.9 is bigger than 3.07. So it will definitely give us the maximum answer. So this is how you solve or you figure out the direction of neutral axis and all of that for every particular case. Any question about this problem?
सर उस पहले वाले क्वेश्चन में हम ये कर सकते हैं सर कि ये z का मतलब इसका भी बॉटम ले ले और दूसरे साइड पे उसका 3 इंचेस ले ले 0.5 के साथ।
क्या कर सकते हैं
सर ये डिस्टेंस z जो हमने पहले इसको 0.5 लिया, इसको हम 0.3 ले ले पूरा और बॉटम पे उसका ले
कर
ले
सकते
सर।
ना, पॉइंट तो हमें क्रॉस सेक्शन के ऊपर ही चाहिए कहीं ना कहीं। देखो हमें पॉइंट चाहिए क्रॉस सेक्शन के ऊपर, या तो ये ले सकता हूँ या मैं ये पॉइंट ले सकता हूँ। ये तो नहीं हो सकता कि मैं यहाँ पे पॉइंट ले लूँ। वी डोंट नीड द स्ट्रेसेस, क्रॉस सेक्शन की स्ट्रेसेस है ये तो।
ओके सर ठीक है।
In this one, we have been provided with two loads. One is this 1,000 pound and the other one is 14 pound. We have been provided with the inclination as well, and the first step we have to do the same thing, that we need to find out the inclination of neutral axis, and the dimension of neutral axis are similar to this problem that we have just completed. And the next thing is we need to figure out the maximum tensile and compressive stress. And this figure over here has nothing to do with this question. This figure is to give you an idea that if I plot this in 3D, how does this inclined load looks like. For example, by this 1414, it is this 1414. Now this is how these loads are basically acting with respect to the cross section. But if you are looking from the front elevation or the longitudinal section, obviously you can't show this as inclined. So that's why you show it with a straight line. But in 3D, you can get the clear idea that how these loads are acting in the inclined direction with respect to the cross section. So this is just to give you a brief idea that how these loads are acting. So coming back onto this one, now in the previous question that we did, there was only one load that was acting in the center. Now in this case, there are two loads that are acting. So for each load, obviously we can do it combined, but that will make things a bit complicated. So we will solve each load separately and first figure out the moments on principal axis due to the two loads, and then in the next question we then we will combine them and solve this one. So first I will consider load 14 pound, and I need to find out the direction of movement, or what are my movement component my on two principal axes, my and mz axis. And by the way, every time we have to transform them onto the principal axis. You just don't transform these. These are the symmetrical sections, so we know that the principal axes are y and z axis, and they have given us the property. If it is not, if there are some different principal axes, then obviously you will be provided with the inclination of principal axis as well. So first, for 14 pounds, if I show this on center line, it will be acting somewhere over here, right? And the angle is given to us as 45 degree. So where will be its movement axis? Quickly. Anyone?
Perpendicular, sir.
So that will be perpendicular to this one, which I will show with here. Now I need to figure out the direction of movement or the magnitude of maximum movement. So what will be maximum bending moment? Let's suppose there is only one load, 14. So what will be maximum bending moment due to this 14? कितना मैक्सिमम मूवमेंट ये प्रोड्यूस करेगा और किस
So ये
पॉइंट?
11312 पे I guess. उधर जो जहाँ पे fixed joint है वहाँ पे सर.
Obviously it will be at point where there is a fixed joint. So fixed joint is at a distance of 10 feet, so that the maximum moment will be 14 into 10, and that will be 14 pound feet, right? Is there any confusion about this one? So if there are no confusion, then we can move on. And now this movement is being produced by this load of 14 pound, and it is producing. Now this point is we have to figure out the direction, whether it is inwards towards the centroid or outwards. Now this movement is being produced in counterclockwise direction, right? So the resistive bending moment will be in clockwise direction. So the clockwise direction shows that I have to show the movement pointing inwards towards centroid. So over here, if I want to represent it, it will be something like this one, and the value of this moment will be 14. Any question about this one? What will be this angle theta, or angle of this horizontal movement?
45 degree.
How much?
45 होगी सर.
So this angle is 90 degree, and the remaining angle will again be 45 degree. So this is my y-axis and z-axis. Obviously, our next step is to transform this moment, or transform onto two principal axes, which are y and z-axis. So on y-axis, the component will be in this direction, and on z-axis, it will be in the downward direction. So my will be, if I show it over here, that will be 14, sine of 45, and mz is equal to 14, cos of 45 degree. So what is the answer that we are getting?
So 999 8.49.
999 999
8.48.
8.4. Okay. And for this one also we will get the same answer in pound feet. And this one is also in pound feet. Okay, so this is we have figured out the direction or the moment component due to this 1414 load. Now, in the same way, we will figure out the moment component due to 1000 pound. And once we have two components, my and mz, we can simply add them and we will get the final my and mz due to the combined effect of both the loadings. So let's just quickly do that. The same practice we have to do with for 1000 pound load. What will be the maximum load or maximum movement? If you look into this diagram, let's suppose now we have only this 1000 pound load acting on this beam. So what will be the maximum bending moment that it produces?
6000 होगी सर.
So that is 6000. So maximum bending moment is 6000 pound fit. And by the way, this 1000 is acting in this direction at an angle of, how much is the angle? The angle is 30 degrees. Okay, so these are the principal axis. Let me just erase it. This is where the 1000 is acting at an angle of 30 degrees. Okay, and the maximum moment is 6000. Now, again, my moment axis will be perpendicular to this one, or it will be somewhere over here, something like this shape. And I know that I have to show the maximum movement on which side. The left side, obviously, because this 1000 pound is acting on the left side of my cantilever beam. So the left side of beam is this downward side. So I have to show somewhere over here. So whether it will be outside or inside, how can you figure out? Again, the same thing that this 1000 is producing the movement in counterclockwise direction and the resistive bending moment is in clockwise direction. So we have to again show it pointing inward. So this will be our resultant moment for this 1000 pound. So can anyone tell me what will be this angle to resolve this moment? This angle is 90. So this will be 60 degree. This will be 30 degree and this final angle will be 60 degrees. So either we can use this angle or this to resolve this one. If I show two components of this movement, one will be in this direction towards right and the other one is in the upward direction, the y component. So mz will be, over here I can just mention the signs of this angle so that we will use the same sign later on in the equation. Obviously we can substitute the signs later on, but we will just do it at this point so that we remember what we did. In this figure, if you see, my was negative and mz was also downward. Sorry, my was downward, so it is negative, and mz was toward right side, so it is also negative. So both of these are negative, and in this figure, I can see that mz is acting towards right side, so it is negative 6000 sine of 60 degree, and my will be negative, and my is acting in the positive y direction, so that will be 6000 cos of 60 degree. So what is the value of mz?
5196.15.
So y is mz is minus 5196.15 pound fit, and my, what is the value of my?
3000 minus 3 plus 3000.
So that is 3000 positive pound fit. Now you can see that for each load I have one value of my and the other value of mz. So I can simply add these two values to get the resultant movements on both axes. So rather than solving it combine in a combined manner. I have solved it separately for the sake of convenience that you don't get confused with the directions or the conventions that we have learned. So the resultant MZ will be minus 999.4 plus, and this is also negative, so negative 5196.15. So what is MZ? And in the same way, My will be minus 9998.4 plus 3000. So what is the value of movement?
Sir, MZ 1516.7.55.
So MZ will be minus 15194 pound feet, and My, what is My? Anyway,
Sir, ये 15167.55.
167. What about the other one? What is My? So I'm getting minus 6996.4, right? So since all the units of dimensions are given in inches, so I can also convert these into pound inch. So if I convert this one, that will give me, I will divide it by 12. So if these answers are in pound feet, so what will be the answer in Gibbs inch? Do I have to divide or multiply?
डिवाइड करेंगे सर.
Divide करना होगा, multiply करना होगा.
सर ये 1.2 किप्स आएगा.
1.2 kips.
1.26. Yes sir.
I think it is 182.3 kips inch, because to convert it from feet to inches, I have to multiply it with 12 and divide it by 1000, right? But we are moving from a bigger unit to a smaller unit. And in the same way, if I convert this one to kips inches, what I am going to get? So this will be negative 182.
3.9.
That will be negative 83.95. So I have two values of bending moments. Now these are my two bending moments, and using these I can solve my whole question just in the same manner that I have solved previously. So this was my section, and if I represent these two moments, both of these are negative, so that means that they are acting in the opposite direction with respect to the original centroidal axis. So this will be my MZ, that My, that is 84, and this will be my My, which is 182.34. And the first thing that we were supposed to do in this question was find out the inclination of neutral axis. Now the inclination of neutral axis is tan beta Iz over Iy tan of theta, right? So what is tan theta now in this case?
45 degrees sir, I think.
45 was the angle of resultant moment when only 1414 load was acting, and that resultant moment is not the neutral axis. We need to find out another resultant moment due to these two combined forces. Now these are our final forces due to both load 1414 and 1000. Now Due to these loads, I have figured out the two components on principal axis, and now based on these two loads, there will be a resultant moment or final resultant moment, right? So उस resultant moment का जो angle होगा with respect to, let's call this as, now the angle from the horizontal principal axis to this resultant moment will be my angle theta. Because if you remember our initial derivation for inclination, the angle theta was the inclination of the final resultant moment with respect to the horizontal principal axis. So what will be this angle? Anyone? If you remember from geometry, we simply can do 84 over
24 होगी
182.
सर 24.73
24?
24.73
How are you solving that? Let me see.
यही आता है सर 24.73.
Okay, yes. So the angle theta is 24.73 degrees. Now if I substitute this angle into this equation, I can directly get tan of beta. So tan beta will be Iz, and Iy was given to us as 112.6 and this was 18.7, and this is tan of 24.73. So what is my angle beta?
So 70.17.
So beta is 70.17 degrees. So this is my angle beta. Now where will I show this? Again, I know that this angle is 70.16 with a positive sign. So that means that this neutral axis will be somewhere in the clockwise direction with respect to the horizontal principal axis. So this is horizontal principal axis, and from here I have to move clockwise 70.17 degrees, and this will be my neutral axis. So this is the first part that we have solved for this question. Now in the second part, we were supposed to find out the maximum tensile and compressive stresses. So for that, again, we have to do a bit of trial and error procedure to find that out. So first, let me just quickly, yeah, we were supposed to find out the maximum tensile and compressive stress. So for that, what we can do is we can take 3 or 4 points, and on those points we can find the values. For example, this was our cross section, and these distances are 3 inches, 3 inches. This was 1 inch, and this height was given to us as 3.07. Okay, so we can take 3 different points. For example, A, D, and B, and we can find out the values of stresses in these particular points, and out of these values, whatever value is maximum will be our positive maximum will be our maximum tensile stress, and the positive or negative maximum value will be our maximum compressive strength. So let's first find out the value at sigma A. Our governing equation was minus mz y over iz plus my z over iy. Now in this equation, if I substitute the value of mz, which we just calculated previously, that was minus 182, I believe. So mz will be minus 182.43. What will be y distance for point A? Anyone?
3.07.
In the positive direction because it is acting upward. So Iz, it was also given to us, that was 112.7. Then My we calculated as minus 84. Okay, and what was Z distance for point A? For point A, if I look into this figure, the Z distance is minus 3 inches. So if you, that is minus 3 inches, and Iy was also given to us 18.7. So what is the stress that you are getting for using this equation?
18.44.
So that will be 18.22. Since we have converted the units into Gibbs inch, so this will be KSI or Gibbs square inch. And this is the positive answer, and this will be our maximum tensile stress. Now, as a homework, I am leaving you, I'm asking you to find out the stresses at these 2 points, D and B. You are going to get negative answer for this one, and you have to figure out that what will be the maximum compressive stress. And I'm giving you the answer of maximum compressive stress as 11.85 KSI. So you have to find out at which point this maximum compressive stress is acting. So this is how you solve the beams for unsymmetrical bending, particularly the symmetric section. So I'm going to stop over here, and this is all about the symmetrical section. In the next class, which will happen after midterm exam, we are going to solve or figure out the unsymmetrical bending for unsymmetrical section. These were all symmetrical section. Next, we have to go into unsymmetrical section. So, any question about this lecture or this topic?
सर ये मिड में इंक्लूड होगा या नहीं ये वाला टॉपिक?